Hey everybody, this is Larry. This is day 10 of the Advent of Code of 2024. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's Advent of Code. Yeah, day 10. Finally, the long streak of non-leaderboarding, of no leaderboarding is over. Yesterday we were able to get on the leaderboard. At least for part one. Part two, I kind of misread the problem, but that's okay. Hopefully, that's not the end of it, though. I'm still going to be doing it today. So, yeah, and we have about a minute to go. I am going to change it to the other setup early because yesterday I almost forgot and I kind of had to hustle in. But the reason why I have this setup is because you don't really need to read the same thing I'm reading. You should be able to just go to adventofcode.com and just like read the poems. It should be okay. So I mean, right? That makes sense, right? Let me know in the comments if that doesn't really make sense. But and when when I talk about the stream the screen, I'll bring it back up. But yeah, otherwise, my getting on the leaderboard at least once mission done, so I'm pretty okay. We have about 20 seconds to go. I am a little bit tired today. I went to the gym. I went a couple too many miles. So we'll see. I was just sitting on the couch right before this, and I end up passing out, and I had to like set an alarm to make sure I wake up for this. So the month of Advent of no sleeping is it's up, and we have about 7 seconds. So let's make it worth it. Let's go. 4, 3, 2, 1. Go go go. Okay. Okay, scores and trail hits. Okay. Yeah. This should have been faster actually. But whatever. It is what it is. And maybe I should have had a VFS score of it. What are you doing, Larry? No. I think I'm choking a little bit under the speed. Don't even need this actually, I don't think. But 88. 177. People are so fast. Can't believe that. It's ridiculous. $153. People are too fast, and I don't even almost believe it. Honestly. This is one of those ChatGPT phase. I want to say, I don't think I was like. This is, I don't know. Like I feel like this entire advent of code, I'm getting like, whatchamacallit, gaslight. Like I'm trying to be like. It's a little bit frustrating, I think that's all, because I feel like I'm trying to remain humble and all these things, and like think good of whatever, but at the end of the day the numbers don't really make sense compared to like the past, right? And some of it is just I talked about this before. As a competitive programmer, you kind of have an internal clock in your head about how fast things are, how fast other people do, and all these things, and where you put on that things, and whether you need to step your foot on the pedal and all these things or not. And some of this is given the bias sampling of who shows up, right? Because let's face it, I'm probably not the top 100 speediest person, but the time zone makes it so that it cuts off a lot of people, right? So let's admit that right off the bat. But like it just feels like today, like I feel like on a regular year, or maybe this is the new regular year, but on a year such as that, like I feel like I had a very good time, a very good pace, right? But that's what it is sometimes. As long as we're having fun, as long as we're kind of going for it, I guess it's fine. How much did I miss by? Let's see. Part 1 is 2 minutes. 2 minutes seems unbelievable. I mean, what was my times again? 3:30. Like I feel like, yeah, maybe I could have typed things a little bit faster. And this is one of those problems where as soon as you see it, you know the solution, right? So I was going, I wouldn't say as fast as I possibly could, but let's say at least like 90% of it as fast as I could have gone, right? I mean, 16 seconds is ridiculous, right? And I guess this is very ChatGPT-able. And maybe I'm only good at problems that are ChatGPT-able, who knows? But I will also say that, like, I don't know. Like I said, like, there are a couple of people I use as, like, the barometer, like 5space and Jonathan Paulson. Also, check out their channels. But yeah, and, when you don't see them, you're like, well, And this part 2 is 4:14 at 5:20. I don't know. Like I could have shaved off some time, not by that much. I mean, and Tisto is very fast unless he wants into something. So if this is his time, like I don't know. Like you have to be really, really, really good to beat him. So that's kind of my parameter. So if you want to say, I mean, I wouldn't say everybody. I don't know. Maybe I would do. I don't know. At a certain point, you're like, well, is everybody under 4 minutes? like I don't know, like it feels like one of those things where like in science there's all this phrase like was it an exceptional claim requires an exceptional proof, but I'm almost like nowadays the math, the calculus has turned the other way where like, well, the exceptional claim is not that people are fast. The exceptional claim is that people are probably using ChatGPT. Or the other way around. I said it wrong. But, you know, like the exceptional thing is not that people are using ChatGPT. The exceptional thing is that people are not using ChatGPT. So, I don't know. So, is it possible to do this under 4 minutes? Like, I mean, I wouldn't be, like, you know, and this is super fast. I wouldn't be surprised if a couple of people beat them. But, you know, 94th is ridiculous. And not even finishing in part 1. I don't know. Maybe I'm getting like salty, bitter old guy who yells at crowds today. My apologies. It's just that, like I said, like I have this internal clock, right? And I'm like, I'm going pretty well. I'm going pretty fast. I know exactly what I want to do. Maybe I could have been like 10 seconds faster or something. But like I said, like reasonably 20, like 90% of what how fast I could have possibly gone anyway. Reasonably. Like maybe I could have gone a little like. If I have template, maybe, but I don't even, like, just for typing purposes. Like, I guess breadth first search is something that a lot of people have on template, possibly. So I guess maybe there's that. Because then if you had the right templates, maybe you only have to add this, and you could save some time. I could maybe see it if you really, really want to be gentle about it. But I don't know. Maybe it is what it is. But all right, rant aside, let's actually go over the solution. I guess we don't need that. Does that block anything? Nope. Okay, so part 1 is just straightforward BFS. So from every 0, we do a BFS, and basically there's an edge for every 0 to 1 to 1 to 2 ... That's what is meant in the problem by gradual. Let me go back to the problem real quick so I can kind of, well, I mean, I'm not showing it anyway, but nonetheless, that's what it means by even gradual uphill slope. So it always increases at height of exactly 1. Up, down, left, right only. So pretty, I think this is relatively standard. You know, it's linear time, linear space, keeping in mind that linear is in the size of the input, right? And the input is size R times C. So this is going to be, you know, they're at most 4 times the number of nodes and edges, or I guess that could never happen because of the edges or the boundary. But roughly speaking, let's just say 4 times n. So it's going to be, yeah. And this is my implementation. I think I don't write it the same way every time. I don't know why I wrote it. I kind of was a little bit lazy, so I wrote it with this set thing. Maybe if I depending on how you want to think about it, sometimes I think this is more of an advent of code thing for whatever reason, because I don't have to think about it as much. But I would probably, you know, just as a thing, like I would maybe convert this to like to an array or something. But also, like, I don't think that matters too much, honestly. But that's what, like, maybe one thing that I've done. You have to change the syntax in the other places, but that's fine. So yeah, so that's part 1 is standard breadth first search. Not gonna go over it that much in detail here, honestly, because there are enough things about it. And I think part 1 is a pretty standard application of it. I think for this particular problem, you can also have done depth first search, because it is not a distance problem. It is a connectivity problem almost, right? As long as you don't revisit the same cell more than once, depth first search would also give you the same result. So this, but I for that kind of invariant, for that kind of property, I prefer BFS as in implementation, just because breadth first search does have no revisiting cells as part of its thing. With depth first search, you have to be a little bit careful, maybe. And I don't think it matters that much. But for me personally, it's just that I haven't done it enough, possibly, right? And that's really the idea. If you really want, because as I said, this is a connected components, a connectivity problem. You could also do this with Union Find if you want to challenge yourself for whatever reason, or upsolve it and practice new algos. Union Find is one of them. So you can also Google Union Find or disjoin set union, right? Something like this. Maybe I made that up. But if you Google them, you should find them. These are all really elementary algorithms. So just playing around with, yeah. And part 2, I mostly copy and paste. I kind of wrote this in a very awkward way. And this is the part where, what was the answer again? Well, my answer was 1459. So I think that's the one thing that it could have gone either way. I don't know what the answer is before I submitted it, obviously. And what I mean by that is that 1459 is actually not bad enough. Like, if that's the answer, then you're not searching too many branches, I think. Maybe I'm wrong on that. That actually, I don't know. I'm not going to confirm it, but the reason why I didn't do it this way is because I didn't have to think about it. And what I was going to say is that you could do, if you do a depth first search, to kind of do a brute force counting all the paths. I don't know that's going to be fast enough. Maybe if pruning is fast enough. Maybe if you do a not visit the same thing more than once is fast enough. Maybe if you add in memorization is fast enough. But honestly, it's very, I don't know. I think there are a lot of ways for that to go wrong, so that's why I don't usually implement it that way. But that said, the way that I did it is with dynamic programming. It may not look like it, but the way that I did it is with dynamic programming. And actually, I don't even bother reusing answers across different things, though you can certainly do, I believe. And the reason why is because this graph, and I didn't point it out in part 1, maybe I should have. I don't think that's necessary for part 1, but in part 2, the thing to realize is that this graph of this grid of a graph is a DAG, right? Is a directed graph. You can make it directed just because it goes in one direction, but as a result of that, there are no cycles, right? I mean, that's not to say that it's a tree, it's just there has no cycles. And as a result, you can use memorization and or dynamic programming. And the way that I did it is with dynamic programming. A lot of it is still off the BFSE code just because, well, it's just shorter to write. I just copy and paste most of it. And the only thing that I changed is that I added this count thing. And count is just given, I think, so there are two ways to think about this, right? And for this particular problem, it is symmetric. And what I mean by that is that you can count from zeros going to 9 or 9 going to zeros. As long as you obviously reverse all the graphs and all these things, it doesn't make a difference to the solution. As long as everything's consistent and everything is correct, right? So that's the first thing. And as a result, the way that I actually count it up is from, there's one. So I count for each node. The count variable contains the number of paths to the current cell. So count sub x comma y is equal to the number of paths starting from the initial point, which is xy from here, right? As a result, I think you can also have, like, if you really want, you could I want to say, no, maybe not. I was gonna say maybe you can do them all at the same time for a little bit of, I don't know if that's a speed up, but I don't think that's true. No, actually, that is true. Yes. So actually, you can actually speed this up by doing all of them at the same time. I didn't do it because, like I said, I copy and paste during the speed rush, but you can definitely do them at the same time. And the reason is because with this particular graph, the property of the grid is that, well, when would you get to a cell of, say, height 5? Well, you get there exactly 5 steps away, right? 1, 2, 3, 4, 5. And that is actually an invariant of the problem, right? That is a property of the problem. That is something that just never changes, actually. So what that means is that both breadth first search and depth first search is that there are no, like, weird paths where one path is longer than the other, right? It's almost like a Manhattan distance kind of thing, where if you get to this, if there are multiple paths to get to the same cell, you always get there at the same exact time, even from different starting points, right? So that's actually a cool idea, and from that you can kind of build everything. And this is kind of, like I said, like a wonky way of doing dynamic programming. So two things I changed. One is that I moved the score from here to the inversion, which it doesn't really matter in the sense that I could add it here where we add the peak of the hike, or when we relax the peak of the hike. Doesn't matter that much, but yeah, but here I just kind of move it there, and the score is just counting the number of paths of starting from XY. Yeah, and then here I just copy and paste from before, but here this is kind of the thing is that the only difference between this line and this line is that I got rid of the not done thing, because even if it's done, we want to count the number of paths leading to the new location NX and Y. So as a result, that allows us to kind of yeah, and I think the code is a little bit wonky because it's not a common way of doing dynamic programming, or like in the sense that it doesn't have like that really cool, really good looking bottom up structure, but it is dynamic programming if you draw the graph in terms of the dependencies and how you when you do updates and all these things. It is exactly the same as dynamic programming. And as a result, also though, I kind of lied on the previous part 1. Now that I realize it, I forgot that. I mean, I said this is linear because of the BFS, but we do actually call this multiple times, so this is actually n squared. So I lied on that. But we can fix this. So actually part 2, it is also n squared for the same reason, because we go for O of n, which is R times C, and the number of cells in this part, and then we do a BFS, which is another O of n. So this is actually n squared. I lied earlier, but actually, as I said, you can actually do this all at the same time. So let's actually upsolve this to increase this to improve this to O of n, right? So okay, so maybe we have like starts. Right, so we just start append xy, right, and then now we can just write score is equal to BFS starts, and then we just have to fix this, right, right. So then now we just have for xy in starts, and this, yeah, okay, I think this should give us the correct answer, and there you go. So now, just, once you kind of realize and play around the properties, apparently you can do this. Like now, I made like 5 lines of code, and we changed it from n squared to O of n, right? So pretty cool, actually, once you kind of know what you're looking for and what you're doing. And of course, you can make similar changes to part 1. I'm not going to do that here because I'm lazy and I'm tired and I want to go to bed, honestly. But no, I mean, that's all I have for this one. Let me know what you think. Let me know if my rant is a little bit out of place. My apologies. I'm just a little bit frustrated because, like I said, I have a mental clock. My mental clock. I keep on repeating that, but then it's just like, I don't know if I would say it's wrong. It's just, let's just say not well calibrated for the new world. So maybe I gotta, Anyway, that is all I have for today. That's all I have for this poem. Let me know what you think. Thanks for watching. Let me know your questions in the comments. And yeah, hope to see y'all tomorrow. As I always, I keep on saying this because I don't know, it bothers me as a pedantic computer scientist with his mind right after finishing edge case problems and stuff like this. But like who knows? Who knows if tomorrow happens, right? So who knows? But yeah, before I go, I guess like these are my current times, in case you're curious. And that's it. Thanks for watching, and goodbye, and I'll see you later, hopefully.